Hi, and welcome to day 4 of complex numbers. Today we're factoring using complex numbers. So we are going to rewrite each expression as a polynomial in standard form, which means we're going to multiply. Okay. For some of you, the box method may be what you choose to do, and that is fine. In this first one, I will have x times x, which is x squared. X times negative I, which is negative I x, I times x, which is plus I x, and I times negative I, which is minus I squared. Now looking at it, those two cancel each other out because one's plus and one's minus, and we're left with x squared minus I squared. But like we talked about in class, I squared cannot be left. We have to change that to a -1. So it's equal to x squared minus a -1, which we all know is x squared plus 1. For the next one, we will do this again. X times x is x squared. X times -5i is negative, not equals there. Hang on. So that would be minus 5i x, and then this would be plus 5i x, and then that would be minus 25i squared. Again, these middle terms are going to go away. And I'll be left with x squared minus 25i squared. But I squared is -1, and -1 times -25 would then be positive 25. So x squared plus 25. This last one is a little bit trickier. I think it might be easier for some of you if we did the box method for this. So if I do the box method, let's see here. This would be x. This would be -2 minus I, because I distributed the negative inside there. And then this would be x, and it would be -2 plus I. So here I'm going to have x squared. We're going to have -2 minus I times x. And here I'm going to have -2 plus I times x. And here I'm actually going to have to do like a box within a box. So off to the side I would do 2, let's see here. The -2 minus I and -2 plus I. So I will have 4 plus 2I minus 2I, 2, and then minus I squared. So those two are going to cancel each other out. So I will have 4 plus 1. So this will then be equal to 5. So let's kind of clean up what we have here. This will be x squared. Then I'll have -2x minus ix, and a -2x, and a plus ix, and a plus 5. And when I look at that, my IX's go away, and I have a negative 2x and a negative 2x. So I have x squared minus 4x plus 5. Okay, if you're wondering how I got this negative 2x minus ix, I just distributed my x through here. And if you're wondering where I got the plus 1 from, again, I squared is negative 1 times the negative here, which gave me plus 1. So, moving on. Factor the following polynomial expressions into products of linear terms. Okay, these are the sum of two perfect squares. We've always said, oh, you can't factor it, it's not factorable. Now that we have complex numbers, it is factorable. So this kind of goes back to what we were doing up above here. If you look at these problems here, I have a sum of two perfect squares and another sum of two perfect squares, and if I look at them factored, they just have an I in the parentheses. So this is simply going to be x, and the square root of 9 is 3, but I know what if I were to set it equal to 0, I say x squared equals negative 9, I'd be taking the square root of negative numbers, so I have a plus 3i and a minus 3i. For number 2, again, I have x and x. 5 is not a perfect square, but I can take the square root of any number. So this would be like saying x squared plus 5 equals 0. So that's x squared equals negative 5. So you take the square root, we can't leave negatives on the radical, so it becomes plus I radical 5 and minus I radical 5. All right, moving on. Consider the polynomial p of x equals x to the fourth minus 3x squared minus 4. What are the solutions? Well, in order to solve this, I need to factorize. So this factors into 0. X squared and x squared. And factors of 4 that subtract to give me 3 are 4 and 1. And it's going to be negative 3, so it's minus 4, plus 1. And we have a sum of two perfect squares and a difference of two perfect squares, so we can factor. So this will become x plus I, x minus I. This will be x plus 2, x minus 2. Which means my actual solutions are x equals negative I, x equals I, x equals negative 2, and x equals 2. When I set each one of those equal to 0. Part B. How many x-intercepts does the graph of the equation y equals x to the fourth minus 3x squared minus 4 have? What are the coordinates of the x-intercepts? Well, only these two are actual intercepts because they're real numbers. So the answer is 2 x-intercepts. And it asks for the coordinates of the x-intercepts. So the coordinates would then be negative 2, 0, and 2, 0. Are solutions to the polynomial equation p of x equals 0 the same as the x-intercepts of the graph of y equals p of x? Justify your reasoning. The answer to this is no, because we have real solutions and imaginary. So we have both real and imaginary or complex solutions. Okay. only the x-intercepts show up on the graph. But when we solved, algebraically, we had 4 solutions. Okay, so if I were to actually graph this function, so you can see I have a root at -2, 0, and a root at 2, 0, and my graph is going to look something like this. But yeah, I have 2 other solutions that we don't see. So that's, I think, sufficient explanation there. Next page. Here we go. Now we're going to write polynomial p with the lowest possible degree that has the given solutions. Explain how you generated each answer. Alright, so the lowest possible degree would be 4 for A, because there are 4 different roots that we see. So we did this in an earlier unit. It was actually unit 2. When we were given the roots and we wrote the equation. So p of x is equal to x plus 2 would be the factor, because remember x equals -2. So if I add 2 to both sides, I get x plus 2. That is my factor. And x minus 3, and x plus 4i, and x minus 4i. Unfortunately, they want us to actually write out the equation, not just in factor form. So we're going to have to do a little bit of multiplying here. So I'm just going to multiply these 2 together and then these 2 together, the real ones and the imaginary ones. This will give me x squared plus 2x minus 3x, so minus x minus 6. And over here, this is x squared plus 16. My middle terms will cancel out because it'll be a plus 4ix and a minus 4ix, and then 4i times negative 4i is 16, negative 16i squared, and negative 16i squared. I squared is -1, so it becomes positive 16. If you need to, do the box method off to the side. And then we need to multiply these 2 together. And when I do that, I'll have x to the 4th minus x to the 3rd minus 6x squared. And then I'll have a plus 16x squared, a minus 16x, and a minus 96. So I have 2 terms really only that are alike. So I have x to the 4th minus x to the 3rd plus 10x squared minus 16x minus 96. So this would be the lowest possible degree polynomial that I can have. For B, I would have a second degree, because I have, third degree, excuse me. Something that we did not talk about before. Whenever I come to imaginary or complex, they always come as a conjugate pair. So negative 3i must also be one of my roots. So let's that one. So complex roots would mean that my p of x here would be x plus 1, and then x minus 3i, and x plus 3i. So this will be x plus 1, and I'm going to multiply those two together, and I'll have x squared plus 9. So I will have x cubed plus 9x, and then plus an x squared plus a 9. So it's x cubed plus x squared plus 9x plus 9 for my function. Those are conjugate pairs. So this one would be to a 4th power again. So p of x would be x minus 2, and it would be x minus in parentheses 1 plus I, and then x plus 1 minus I. So these two are going to be a little bit harder to multiply. Here I will have x squared minus 2x. Yay for easy. And this other one, if I distribute my negatives, it might make it a little bit easier for you to see. So the x minus 1 minus I, and then x hang on one second. I gotta go back here and change the sign. This should be a negative, not a positive, because that's a positive 1. That's my bad. So it would be minus 1 plus I. And I can group inside. I have an x minus 1 and an x minus 1. So it's x squared minus 2x times x minus 1, the quantity squared, and then it would be minus I squared. So we will have x squared minus 2x times, if I clean this up, I will have, if I multiply here, I will have x squared minus 2x plus 1, and then the I squared minus I squared becomes another plus 1. So it's x squared minus 2x still, and x squared minus 2x plus 2. And now we get to multiply one more time. Lots of fun. X to the 4th minus 2x to the 3rd plus 2x squared. Here I'll have a negative 2x to the 3rd, so I'm going to line up my like terms underneath to make it easier for me. Minus 4x squared and a minus 4x. So I will have equals x to the 4th. Negative 4x cubed. And why do I have a negative here? This should be positive. Plus 6x squared minus 4x. Wow, that was rough. Let's save D for in class and E in class again instead of being sure. These are going to be a little bit tougher. If you feel like you want to try, by all means, go ahead. But we will definitely go over those few in class. All right. There you go. That's factoring with complex numbers and also writing equations given the roots of complex numbers as roots.